Welcome back. So in this video, I'm going to look at how we can make some calculations using the sign convention and the mirror formula. So now for the mirror formula, we're going to derive some formulas we use in solving all this problem. Now the first thing is that we have 1 over f is equals to 1 over u plus 1 over v. So this is the first formula. Then we have what we call magnification. So magnification, that's m. We call it linear magnification. So this is linear magnification. M is given as the image height over the object height, which is the same thing as the image distance over the object distance. And the image distance is the same as v, and the object distance we use u. So these are basically the formula we use in our calculation. We are going to use for our calculations. Then we might have that m, that's the linear magnification, whenever it is negative v over e. So this negative shows that the image form is real and inverted. So that's the property of the image form. Whenever we have a linear magnification to be negative, it means it is real and inverted. And if you take the absolute value of m, if m is less than 1, and if the absolute value, so if this is less than 1, that means the image is said to be diminished, and we know what diminished is. That means it is smaller than the object. And if we have m to be greater than 1, we say the image is magnified. So we are going to be using this as well as the sign convention, which I said we are going to use real positive only in our calculations. So the first question here, of course, the first question here is determine by calculating the distance of the image formed and the focal length of a concave mirror. So here we are solving for concave mirror. So you can go back to the sign convention for real is positive and see what we are going to do here. So of a concave mirror, if the height of the real image formed by a 6 centimeter object, if the height of the real image formed by a 6 centimeter object, so clearly from this now, that means we are given the object distance. So I'm going to use DO as object distance. Sorry. Let's say object height, H subscript O as object height or object size, which is given by 6 centimeters. Place 15 centimeters from the mirror if the height of the real image, so this is the height by a 6 centimeter object, place 15 centimeters. So that means we are giving you to be 15 centimeter from the mirror is 36 centimeter. So the image form is 36 centimeter. So V is 36 centimeter. Okay. Look, this will be the height, that is image size. Determined by calculating the distance of the image. So we are looking for V, image form, and the focal length. So we are looking for focal length also. So given this information, so clearly we can look at what we can use here. Now I can't use this formula since I don't have V and I don't have F, so I can't use this formula for now. But I can use this to get V. So what will be here is that since we are given image height over object height is equals to image distance over object distance from the magnification. So we have that image height over object height is same as image distance over object distance. So clearly V is equal to U HI over HO. So U is given as 15 times HI, which is 36 all over HO, that's 6. So when we do this, that's 6 times 15, so we have 90 centimeters. So that's the first question. So we've answered for the image distance. Now to calculate for the focal length, so we are going to use this first equation, which says 1 over F is equals to 1 over U plus 1 over V. So U is given as 15 plus 1 over V, that's 90. So we can use our calculator here to find this. So if you do this correctly, you should be having 7 all over 90. So 1 over F is 7 all over 90. So we can say F is equals to 90 all over 7. So that's 12.86 centimeters. So this is the focal length for this particular question. Now going to the next question. So you can feel free to pause the video and try to answer the second question. So for the second question, a convex mirror of radius of curvature 40 centimeters. So here we are dealing with convex. And for the real positive sign convention, we say whenever we have a convex mirror, the image form is virtual, image distance is negative, as well as the focal length. So those are the properties we are going to use. So the radius of curvature is 40 centimeter, produces an image 10 centimeter from the mirror. So V is 10 centimeter from the mirror. So since this is a convex mirror, our V will be negative. Then calculate the object position and the magnification. So the object position, that is, we need U, which is the distance of the object from the mirror. Then, so from here now, for me to use this mirror formula, I need the focal length, which is F. But there's a relationship between R and F that says F, focal length, is equals to the radius of curvature all over 2. So which is equals to 40 over 2, that's 20 centimeters. So I can now use the mirror formula to calculate for U. So 1 over F is equals to 1 over U plus 1 over V. So 1 over F. Remember, I said f will be negative. So our f here will be negative. So I'm having negative f is equals to 1 all over u. That's what we are looking for. Then our v here is minus 1 over 10. So it is negative. Now, if I make this subject, okay, I already have f, which is 20. So making u the subject of the formula, 1 over u. So we're going to have 1 over 10 minus 1 all over 20. So solving this, we have 20. So this will be 2 minus 1. Yes. So 1 over u is equals to 1 all over 20. So u is equals to 20 centimeters. So that's it. Then the next question says we should calculate calculate the object position and the magnification. Now magnification is image height over object height, or is same as image distance over object distance. So here I'm having v over u. So v is minus 10 centimeters over, and u, which we just calculated, which is 20 centimeters. So our linear magnification will be, so if we do this correctly, we have minus 0.5. So this doesn't have units. You can see clearly from here that this cancels this. So there's no unit. Now, I already told you the properties of the negative, which is what? Real and what? Inverted. So, okay, we are not to use this. So, our magnification actually is negative of this minus of this. So, we have a positive here. And the positive shows that this image form is virtual and it is diminished. So if you take the absolute value of n, which is less than 1, so this is less than 1, which shows the image is diminished, that is, it is smaller than the object. So that's all for this problem. So for question 3, so you can go ahead and try question 3. You can pause the video and try it out. So for the third question, what will be the possible position of an object placed in front of a concave mirror? So here we are dealing with a concave mirror of radius 2 meters. So we are given the radius of curvature to be 2 meters, so as to project an image enlarged 3 times. So when you say an image is enlarged 3 times, so we're talking about the linear magnification, which is 3. So what will be the position of the object? So we're looking for position of the object, which is u. So what formula I'm going to use? Now I have my magnification. So from here now, I can find f, the focal length. So f is r over 2, and r is giving us 2 meters all over 2. So f is equals to 1 meter. Then from magnification is v over u. So, and I'm given n to be 3. So 3 is equals to v all over u. I can say v is equals to 3u. So I have this equation also. So putting this into the mirror formula, which is 1 all over f is equals to 1 over u plus 1 over v. So this is a concave mirror, so our F is positive and V will be positive as well as U. So 1 over F, our F is given as 1. So be careful with the sign. Here we are working with meters. In the previous problem, the unit is centimeters. So 1 over 1, which is equals to 1 over U, which I don't have, plus 1 over V. V is given as 3U, as 3U. So taking the LCM here, you have 3U. Then this will be 3 plus 1 is equals to 1. So I have 3U. If you cross multiply this, 3U is equals to 3 plus 1, which is 4. So therefore U is equals to 4 all over 3, which is 1.33 meters. So that's what the questions asked for. What would be the possible position of the object placed in front of you? So that's the distance here. So in this video, I think we learned how to use the sign convention, that's the real positive, as well as the mirror formula in solving these problems. So thank you very much for watching this video. Make sure to subscribe and hit the like button. See you next time.